All right, the next lesson is going to be covering Newton's laws. Remember that there is also a module called the application of Newton's laws, which goes to more details of the application and the practice problems of the 3 laws of Newton. So we're going to start with the basics and kind of talk through some examples, but keep in mind that a lot more detailed and, to be honest with you, a lot harder practice problems are going to be in the next review lesson. So, the first practice problem states, calculate the net force needed to accelerate a 2,050 kilogram car from 2.17 meters per second to 9.40 meters per second over a distance of 286 meters. So the first thing we need to know is to be able to look for acceleration. So let's look at the formula sheet, and there are a few formulas that you can use, but this one I'm choosing to use is the velocity squared equals the initial velocity squared plus 2 times acceleration times distance. So then we rewrite the formula for acceleration and get this formula, and then we plug in what we know. So we have the velocity, so 9.4 squared minus 2.17 squared, and this is all together in parentheses, divided by 2 times 286. Alright, so then we solve the top and bottom and then divide those two numbers, and we should get 0.146 meters per second squared for acceleration. Alright, so now since the problem is asking you to calculate the net force, we know that force equals mass times acceleration. We now know acceleration, and now we know the mass because it's given to us in the problem. So we just plug in what we know, 250 times 0.146 from acceleration, and we should get negative 300 newtons. Practice problem number 2. All right, it states an ultralight airplane with a mass of 87.5 kilograms is accelerated by a propeller that applies 468 newtons of force. If the plane starts from rest, how far down the runway has it gotten in 12.6 seconds? So we have to understand that the question is asking us distance. And in order to start calculating for distance, we first need to know the acceleration. So we're going to use that force equals mass times acceleration formula and solve for acceleration. We plug in what we know, 468, which is coming from the problem up here, divided by 87.5 kilograms, which also came from the problem. And if we put that in our calculator, it should be 5.35 meters per second squared. So now, since we know acceleration, we must calculate the displacement. Now, if you're wondering, if I can go back, why or how do you know when to calculate for acceleration? Think about this formula. If we didn't calculate for acceleration, we would have 2 unknowns, the displacement and then the acceleration. So that's why we have to know the acceleration first before we calculate the displacement or distance, because it's asking how far. So if you look at the formula up here and say, well, I can't use this because I don't know 2 unknowns, think about, can I calculate acceleration? And we can by using these formulas because the problem gave us the force and the mass. Alright, so going back down here, now we need to calculate the distance. So we plug in what we know. So we have 0, the initial velocity, times 12.6 plus 1/2 times 5.35 times 12.6 squared. Plug that into our calculator and get 425 meters. Alright, here's practice problem number 3. It says determine the mass of a truck that slows down from 300 32.7 meters per second to 15.9 meters per second in 4.31 seconds. If the brakes apply an average net force of 8,780 newtons. All right, again, first we need to calculate the acceleration. And like I said before, we have to calculate acceleration because it's asking to determine the mass of a truck, and it's given us velocity in time and a net force. So we have to find the mass, but before we can find the mass, we have to calculate for acceleration. In order to do that, we have to use this formula, V equals V naught plus A times T. Rewrite it to solve for A and plug in, and you would plug in 32.7 for the initial velocity minus 15.9, and then you're going to divide that by 4.31, which is time, and you should get negative 3.90 meters per second squared. And we know that it's negative, and that checks out because the problem does say that they're going to apply brakes, so it's going to be a force applied in the opposite direction. So now we take the acceleration and the force and now solving for mass down here. So negative 8780 divided by negative 3.90, and you should get 2250 kilograms for that final answer. And probably y'all are wondering why this negative. So remember that if a force is negative, it has to be producing a negative acceleration. So that makes more sense. So if there's that negative acceleration that we got in that problem, that's why that negative is there in that problem. Alright, I did want to point this out because this is the most missed multiple choice question excuse me, from this module. So let's talk about it for a little bit. It says a 10.0 kilogram gun fires a 0.200 kilogram bullet with an acceleration of 500.0 meters per second squared. What is the force on the gun? So it's asking about the force. So remember that the gun applies a force on the bullet, and the bullet applies the same force on the gun. Because of Newton's law, we know and can assume that. So we need to determine the force on the bullet. So how you do that is by using the simple formula, mass times acceleration. We know the mass because it's given to us in the problem. And we know acceleration because it's given us in the problem. We plug that into the calculator, and that's 100 newtons. Believe it or not, this was the most missed test question for that unit. And that is it for this module.